This right here, this was the wall. The entire tech industry was about to slam into a wall. For decades, everything was driven by Moore's law, this idea that chips get twice as powerful every couple of years. But that engine of progress was about to die. And to get why, you just need to understand this one process, lithography. Don't worry, the simplest way to think about it is like a super sophisticated projector, or a stamp. You shine a light through a blueprint of a chip, and that pattern gets printed onto silicon. The key thing is, to make the circuits smaller and more powerful, you need to use a finer kind of light. And this right here, this was the wall. For years, everyone used something called deep ultraviolet or DUV light, but its wavelength was just too long. It was too blurry to print the tiny circuits the industry needed next. So they needed a totally new kind of light, extreme ultraviolet or EUV. It's got a wavelength 14 times smaller. The only problem, this light doesn't really exist naturally on Earth, and it gets absorbed by pretty much everything, even air. And that sets up the main event of our story. ASML's 30-year quest to build a machine that could somehow create and harness this impossible light. A machine that a lot of very smart people said could never, ever be built. The engineering inside these things is just, it's mind-bending. To create that UV light, they take a massive, high-power laser and fire it at a tiny drop of molten tin that's smaller than a human hair. And they do that 50,000 times every single second. And each one of those 50,000 strikes creates this tiny ball of plasma that hits 220,000 degrees Celsius. I mean, that's 40 times hotter than the surface of the sun. All happening over and over again inside this one machine. And get this, because EUV light is absorbed by glass, they couldn't even use lenses. They had to invent the most perfect mirrors ever made by humans. The precision is just staggering. If you scaled one of these mirrors up to the size of Germany, the biggest bump on it would be less than a millimeter high. It's almost impossible to imagine that level of perfection.